In this warm-up, think back to yesterday's lesson. We discussed how we look at which one is longer in order to determine the sign of the answer. 5 is longer than -3, so that's going to be a positive answer. The difference between the -3 arrow and the 5 arrow is 2. In this problem, both of them are negative, so our final answer will also be negative. This is going to continue going farther into the negatives because those arrows don't head opposite directions. They both go to the left. So we have -7 and -4 combined to make -11. Complete these warm-ups and then move on when you're ready. In each 5-number pentagon, find the one number that is the sum of two other given numbers. Transfer all 5 sums to the puzzle below to create one final puzzle, and then solve. So you can see they've circled (4) and -7. If I add 4 and -7, that gives me -3, so they wrote it down here. If we look at this pentagon, well, -3 and -8 would make -11, but there is no -11 in that pentagon. -8 and 4 added together would make -4, but there's no other -4 in there. -3 and 4 would make a +1, not a -1. If I combined -8 and 3 together, that would give me -5. If I combine 3 and 4 together, that would give me +7. 1, -1, and +4, those combine together to make +3, right? If we go forward 4 and backwards 1, we would end up at +3. So we are going to write the 3 down because that is the sum piece. Okay. I see 1 and -1 would make 0. There's no 0 there. Oh, but 5 and -4 together, would that make +1 or -1? The 5 is longer, so it would be +1. If I combine 5 and 2, that gives me 7. There's no 7 there. 5 and -2 is 3. 4 and -2, that combines together to make 2. We go forward 4 and backwards 2, leaving us at 2. This one I see -3 and -5 combine together to make -8. Now we need to find the answer to this one to get our final answer. If I combine 3 and 2, that makes 5. No 5. 3 and 1 would make 4. Ooh, but 1 and 2 combined together to make 3. So our final answer to this puzzle is 3. Here it says create a Kakuma. Create your own Kakuma puzzle by using the blank puzzle shown. Refer to problem 1 and make sure that your Kakuma puzzle follows this structure. Use integer values from -9 to 9. The same integer cannot be used more than once in a pentagon. In class, your teacher will provide you with a card that indicates what your final answer should be. Your number will be between -1 and -9. We're going to use -4 as ours for this example. Now we're going to work backwards, filling in values between -9 and 9 to create this kakuma. So we're actually going to start here and then build upwards. So -4 needs to be our answer. What two values can be added together to make -4? How about -6 and +2? Now we need other values that would not work to create -4 or any other combination. How about a 1? If I put a 1 and a -4 together, that would give me -3, so I can't put that here. If I put a 1 and a 2, that would give me 3. A 1 and a -6 would be -5. A -6 and a -4 would be -10. How about a 0? Will any of those combine to make 0? No. Okay, so now I know that I need 0 somewhere in here. -6 will appear somewhere in here. 2 needs to be in E. A 1 needs to appear in D. And a -4 needs to appear somewhere in C. So we're going to build off of that. I need two numbers that combine to make 0. How about -3 and +3? Let's throw a 5 in here. If I did 5 and -3, that would be +2. If I did 5 and +3, that would be 8. But I don't have any combinations that would make 9, so I could put a 9 there. What are two values that combine together to make -4? What about -9 and +5? Now I need two other numbers that will work in there. Let's just pick one. How about a -2? These together would make -6. These would make +3. Those would make +1. How about a -1? Will any of those combine to make -1? I don't think so. All right, I need two values that add together to make 1. How about 3 and -2? Let's pick another number. How about 8? 8 minus 2 is 6, so I can't put a 6 there. 8 plus 1 is 9, so I can't put a 9 there. 1 plus 3 is 4, so I can't put a 4 there. Could I put a 0 there? I don't think any of those would combine to make 0. What two things can add up together to make 2? About 3 and -1. That would make 2. 2 and negative 1 would make a positive 1, so I can't use 1. Maybe if I create a list, that might help organize my thoughts. So I can't use a 2, can't use a 3, can't use a negative 1. Negative 1 and 2 make positive 1. 2 and 3 make positive 5. I could use a 7. 3 and 7 make 10. That's not on the list because it's not between negative 9 and 9. 7 and 2 make 9. 7 and negative 1 make 6. I already used a 7. 7 and negative 8 would make negative 1, so that wouldn't work. How about negative 6? Negative 1 and negative 6 make negative 7, so that won't be an issue. Negative 6 and positive 3 would make negative 3. 2 and negative 6 would make negative 4. So I think that might work. All right, for this one, we've got negative 6. That would be negative 9 plus 3 make negative 6. Well, negative 6 and 3 make negative 3. How about 0? 0 and negative 9 would make negative 9. And 0 and negative 6 make negative 6. What if I threw in a negative 1? Negative 6 and negative 1 make negative 7. That's not in there. Negative 6 and positive 3 make negative 3. That's not in there. Negative 1 and 3 make 2. That's not in there. So I believe this would work. So really we're starting with our final answer of negative 4, which was on the card that your teacher provided. And then we're building backwards to create the rest of the puzzle. We need to place these in the corresponding pentagons, and then we need to pick 2 numbers that add up to make those. And we need to make sure that when we fill in the rest of the numbers, they don't cause any issues or create any other 3-number sentences that would add up to make a possible alternative answer. There are other puzzles for you to try. This one says, in each 4-number square, find the number that is the sum of the 2 other numbers. Use all 4 sums to create one final puzzle and solve. So you can go ahead and try out the fraction one on your own and see if you can determine what the final answer is. You might want to change some of these fractions to a different denominator to be able to add them. If you have additional time and you would like to try and create a fractional Kakuma on your own, feel free to do so on page 57. Make sure your warm-up is complete, your Kakuma is finished, and then that you've created your own in your workbook.